I know, right, Claire?
Thanks, Em. Ricky, no, you condensation!
Oh no!
That was really close with Ricky. It could have been really bad.
Look, here comes Charlotte.
What about Ricky? What a shame.
Shut off, mate! You stole Lewis!
Can't touch this.
I know I act mean sometimes, it's just because I'm jealous. I want friends too.
Don't want anything.
You know what? I'm gonna get my revenge.
Okay, so if our problem is Charlotte or Sydney is filling water into a spherical balloon so that its volume increases at a rate of 10 centimeters cubed per second. How fast is the radius of the balloon increasing when the diameter is 6 centimeters? So first things that we want to identify is what we already know. What we know is the rate of change of the volume, dV over dt, is 10 centimeters cubed per second because it says it up here in the problem. The next thing that we know is the radius because we know the diameter and the radius is diameter divided by 2. So the radius is 3. Now we have to identify what we need to find. What we need to find is dr over dt, which is the rate of change of the radius with respect to time, which is t. Next, what we do is we find the equation that we need to differentiate in order to find dr over dt. And for this, we're looking for the equation for volume of a sphere, which is v equals 4/3 pi r cubed. Now what we have to do is differentiate both sides with respect to time, represented by t. On this side, we differentiate so it's dv over dt, which is the rate of change of the volume with respect to time. And over here, we differentiate this part of the equation using the chain rule. So what we do is we first take the derivative of this, so it would be 4/3 pi because it's a constant, and then we take the derivative of r cubed, and it's 3. When you subtract 1 from up here, it's r squared. Then next, you have to take the derivative of what's inside, which is just r. And the derivative of r with respect to time is dr over dt, which is, in fact, what we're solving for. If you want to simplify this equation, it would be dv over dt is equal to, and if you multiply the 3 times the 4/3, you'd get 4 pi r squared, and then you just have the same dr over dt. So now using this equation, dv over dt is equal to 4 pi r squared times dr over dt, you can now plug in the variables. We know that the volume is increasing by 10 centimeters cubed per second, so we can plug in the 10 here, and you have the 4, and then you can plug in your radius right here, and we know our radius is 3, and you keep this the same because this is what we're solving for, and it's what we don't know. In order to solve this equation, you just have to do normal algebra, in which you have to bring this by itself. So first what you have to do is divide by 4 pi times 3 squared, so which is 4 pi times 9, which is dr over dt. And this can be simplified down to 10 over 36 pi, because 4 times 9 times pi is equal to dr over dt. This can be even more simplified to 5 over 18 pi, which is your dr over dt, or you can put it in decimals, which is 0.09 approximately centimeters per second. And this, both of these, all 4 of these actually, represent how fast the radius is increasing when Charlotte is filling up the balloon.
Ladies and gents, this is the moment you've waited for.
And then she's back. I feel a lot better, you guys.
Good.
We had a run-in with Charlotte.
Really? Charlotte?
Yeah. Oh look, here she comes.
Take this!
No! I don't think so.
Oh no! That's what you get, you bitch.
That's what you get for messing with these mermaids.
Yeah.
I've got a special power that I'm not afraid to use.
I got a special power that I'm not
change. Let's put this on here.
I could be really bad today with Ricky. We caught it really close.
Look, here comes Charlotte.
What about Ricky? What a shame.
Shut off!